Hello viewers, welcome back to the Multimagic channel. Myself is Funny. Hope everyone are doing good. As you know, Multimagic is a media application and as a part of this product development, we have been discussing various features that adds more value to the product. So as a part of that, we have discussed a couple of interesting features in the last couple of video. One is about compression, where you can compress the media file based upon the parameters like bitrate or max B frames and other key important parameters. Also, we have discussed about how to control the playback speed of a video, like whether you can double the speed or 1.5x times the speed, or you can decrease the speed in a slow motion. So we have seen those, how that particular features have been developed and added value to the product. So now we will be discussing about one more interesting feature which I personally feel adds more value to the product from the fun point of view. This is like reversing the video. So I thought, okay, this will be a bit fun, but interestingly it is a bit challenging. It's not that straightforward because it is like storing some buffers. Of course, concept wise it is a bit straightforward. So let's jump into that and let's see the fun part of this. Okay. So as you know, a reverse video is a process where you can take the existing video and create a new video file that plays in the reverse. So it's straightforward. Like there's a video, and if you reverse it, and that's called reversing the media. So before jumping into this, let's see how we can do this reverse using FFMPEG commands. So in the FFMPEG, you have FFMPEG-I input MP4, and this is the video filter, and this is the audio filter. This is the video filter, and this is the audio filter. And the video filter is called reverse, and audio filter is called a reverse. So with the help of these two filters, we can reverse the both audio and video, and we can save that into a new file called output.mp4. Okay, and in the same way, we can just only reverse the video. We don't need any audio in that particular. Then we can use this particular command, and we can tell -an, which means no audio. Okay, just only reverse the video with the help of this video filter. And today we'll be implementing this particular logic, how to do this as a part of our Multimagic's product. We'll go through the code shortly and the architecture diagram as well. And there are also different variations in this reversing. You can reverse video and copy as video as it is. It means like frames will be from back and the audio will be from the forward direction. And also you can do this where reverse audio. Your audio will be reversed, but the video will be in the forward direction. And you can reverse the audio and there is no video. It means you are extracting audio in the reverse direction. So this looks a bit interesting, as we have a lot of combinations in this reverse where you can only extract, where you can reverse only video, reverse only audio, both, or keeping one as it is and altering the audio and video. So these are the possible combinations while if you want to reverse any media file. But our interest is these are just the command lines. These are not any product development or how do you achieve this. So now let's jump into this, how to achieve it. So before going to the code part, let's briefly discuss about the high level overview of what is a reverse means. So here we have an MP4 file. So an MP4 file is frames. It has like n number of frames. Like for example, it has 2000 frames. So as we have been discussing throughout our videos, with the help of this FFMPEG APIs called AV read frame, which continuously reads the frame from a file until the end of file is reached. So for each frame, we will be calling these two APIs simultaneously, called send packet and receive frame. So send packet will just, whatever packet we received from this busy loop, we send that packet, and that packet will be of the compressed format. And now that compressed format will be decompressed and will be converted into the frame, and then it will be sending it, and that frame will be received via this AV codec receive frame. So AV codec receive frame will be receiving a frame which is a decompressed frame or called as a raw frame. And here, as we are only interested storing the video related frame and we don't want any audio related frame, I'm just storing the V frame, which means the video frame here, and until the end of the file is reached, I am storing all the video frames into a buffer. And this buffer is a buffer or a vector of AV frames, and here we will be storing all the frames until the end of file is reached. So usually what we do is, for each frame we encode it and then we delete this frame, and then again we read the next frame and then we encode that frame and we delete that frame. So like that we will keep on going. But in case of reverse, we don't need, we will not encode immediately because we need the last frame. So for that purpose we will store all the frames in a buffer and we'll complete the decode processing first, and now we kickstart the encoding process. So in the encoding process we'll first read the last frame, and for this and interestingly we don't we read this frame as it is, but you also want to adjust the PTS and the packet PTS. PTS means as using present timestamp. If you don't adjust this, what will happen is, even though if you reverse the video, that the time duration will be like, it will be from, let's say if you have a video of 22 minutes, it will be like 2 minutes 1 second, 2 minutes 2 seconds. So from there it will go. It's not correct. So we need to adjust the timestamp also accordingly. Accordingly in the sense, for the last frame you need the timestamps of the first frame. For the last but one frame you need the timestamps of the second frame. So like that you need to write some logic here, such that each frame has the exact the sensible PTS and DTS values which are at the beginning of the frame things. So once the frame is ready, you can send that frame, and this will be now send frame will do, which will compress this frame, and that compressed frame is called as packet, and we will receive this packet, and that compressed data or packet will be finally returning into this file, MP4 file, with the help of this AV write. So this is how we do the reverse. The key thing is, we don't encode each frame. Once you read the frame, you encode the frame and you write it to the file. So that's not happening here. It is like you need to wait and you need to start the encoding process unless and until all the frames are written into the buffer, then only you start the encode process, because reverse means it depends on the last frame, and you adjust that frame properties and then you encode. So that way you will be getting the exact reverse thing. So now let's look at the code part of it. So this is our code actually. So where you can see here, this is where actually the things are, process frames. So as I mentioned, there is a busy loop, AV read frame. We are reading from the file, and we are only interested of the video frame, and we at this point we are only reversing the video frame. We are not reversing the audio frame. That will be covering in the next video. In the form, as a part of reversing video frame, we go to this particular thing called transcode video. So here actually where the exact things happen. So as I mentioned here, so once I receive the frame, this frame, so I have the raw frame here. So I am just storing this frame into a buffer. So with the help of this function, store AV frame buffer. So this is the buffer actually. So this is the vector of type AV frame, where you can store audio frame, video frame, or audio video frame. Anything can be stored in this particular buffer. So now let's see how we are pushing the data into this buffer. So we have to be carefully, we don't want, since we are passing a pointer here, we don't want to push the pointer to the buffer. We want, because if you push the pointer at some point, it is like you are accessing the actual data. So you want a shallow copy. It means whatever the data inside this frame is there, you need to copy the entire details of that frame into the buffer, not the pointer. So in that case, you have to allocate a new frame here. You have to allocate a new frame, and then after allocating the new frame, you have to put the parameters like format, width and height manually like this. So okay, this new frame will have format of this input frame, and this width will be of this, height will be this. And then these are the useful APIs here. AV frame get buffer. So here we are only copying the properties of the frame, but not the actual data. So to get the actual data, we need to call this function called AV frame get buffer. So this will first allocate the buffer. It will not even start copying, but whatever, it will start the preparation for the copying. First you need to copy the properties, and then you need to copy the data. So here this additional thing is required because we just want to ensure that these things are not using any defaults. So that's the reason usually this AV frame copy and AV first you copy the properties. So this is the destination frame, and this is the source frame, input frame. So from the source we are copying to input all the properties, and then later you are copying the data. So AV frame copy properties, only copy the properties, and AV frame copy we actually copy the data. So to make these two work properly, we are just calling this AV frame get buffer, and we are just allocating some any kind of this initialization things. So this is how you copy data from one frame to other frame. Okay, so here we copy the data of input frame to temp frame, and now of course, just for the precautionary thing, we are just, and anyhow this AV frame copy properties take care of copying all the properties. Just to ensure, from precautionary point of view, I'm just again allocating the PTS and packet underscore DTS explicitly from the input frame. These are just the since these are the key properties, I just want to ensure, apart from AV frame copy, I'm just making it sure that I am getting those values exactly here. So now that way the actual frame data, the first frame data, is pushed into the buffer. So like that, for every frame we get the frame, we copy the frame using this API's AV frame copy properties and AV frame copy, and by explicitly initializing few variables, we just copy that entire frame data to the new frame, and we are pushing that to the buffer. So until now it is good. So now, as a part of process frames, this is the decoding block. So now you want to encode it. So before encoding, so again we need to follow the similar the reverse strategy now. So now here I am taking one more frame called reverse frame. Okay, so since it is again a pointer type, we need to do one more copy here. So from the buffer I am copying it to reverse frame. It's one more frame, and then I am following a similar structure. I am initializing this, and I am copying all the details here, and I am copying all the information here. Since it is of type pointer type, AV frame is of type pointer type, we just need to ensure we are just not copying the properties, we are copying the actual frames. So but you can mention that why we need two copies here. See, because the original frame has PTS and DTS of, so let's say if you take a last frame have its own PTS and DTS, and the first frame will have its own PTS and DTS. Okay, so now if you don't copy, and if you start modifying the PTS and DTS with the help of a pointer, what will happen is, after you reach a half point, the previous frame information will have the old values, so that information will not become properly. You understand the point, right? So let's say you have 100 frames, and you start reading from last frame, and then you try encoding that last frame, but you change the PTS and DTS with the help of the first frame. So since it is a pointer type, indirectly you are changing the values of the PTS and DTS of the first frame, not the last frame. Since you are reusing it, that's a secondary thing, but that way when you're playing with the pointer is not that straightforward, swapping the data and understanding it. So the better way is, yes, there is a duplicate, you need to copy it one more time, maybe you'll come up with a better logic. But the thing here is, you need to first from the file, you need to copy it into a buffer. The frame you need to copy as it is and put it in the buffer. So now this frame you need to copy into a different AV frame and just adjust the PTS and DTS. So that's what we are doing here. So you just reverse the, you just take the frame we are reading from the reverse direction, and then we are taking the frame width, height, and then we are copying all these things, and then and this is the key thing here. For this reverse frame, we are putting the PTS and DTS of the first frame. -1 -i arrow PTS and -i packet arrow DTS. So that way we are not disturbing the original packets, and then we are correspondingly reading the required PTS and DTS. That's why we need a special copy here. Okay, so but here we are not creating entire buffer. Once we copy the, here we are not creating the entire buffer. In the second case, we are just copying this frame, and we are swapping the we are reallocating the PTS and the packet underscore PTS values, and then we are deleting it immediately. It's not like you are storing the entire buffer. Initially we are allocating memory to store this entire buffer, but while reversing we are only allocating memory for one frame, and we are adjusting the PTS and DTS for it, and then we are encoding it, and then we are deleting it. That way we are optimizing the memory a bit. So that's what here happening. Immediately once that frame is encoded, we are just unreferencing it and we are freeing it. So that way we are just only, every time we just, for each frame we are just allocating one frame memory and we are deleting it, and again we are coming back to the next frame. So like that we need to read all the frames from the reverse in that buffer, copy that data into a new frame buffer, not buffer, into a new frame memory, and then just reverse, use the required PTS, present timestamp, and of the beginning frames, and then you just free it. And at the end you need to clean the memory, like whatever there in the initial buffer, you need to clean that buffer, like AV frame free will this buffer, you need to clean this buffer. So once that buffer is cleaned, and then this is just one more thing just to ensure there is no such map or vector exists again. So now these are all the cleanup process. So that's why what we are doing is we are reversing the video using this particular APIs. So now let's run this code. Actually, I have already used these properties. This is our application, and then this is the library that our application is depending on. And these are the debugging things. -f means function type, 7 means reverse, and -i means input file, and -r is we want to do reverse, and 1 means only video, just only reverse video and ignore audio. So just this is for our internal purpose, we kept like this, but ultimately this particular command line, if you give to our Multimagix application, it will convert, it will reverse the video ignoring audio. So now let's run this. So let's see what's happening now. Okay, it started. So there are, I believe in this is a Iron Man trailer. So it has around close to 4,000 frames, and initially we are reading each frame, and I'm just printing the timestamp of that, and then now I'm just reading that frames in a reverse order, and then I'm just printing the required PTS and DTS that each frame has in the reverse order. So it has close to 4,000 frames. Once that is done, we can just play the video and see what's happening. Okay, this looks interesting. Okay, let's keep going. So yeah, as you know, a lot of copies as pointer copies, actual data, actual point. Yeah, it's done actually. So now let's see. So now let's go to the download section, and then if you can, yeah, this is the latest one. And if you go here, and if you play with VLC player, yeah, this is the end titles. Let's move. Yeah, it's playing from reverse now. You can see it's going in the reverse direction. Yeah, so everything is reversed now. Very fun. Yeah, okay. Okay, yeah, you can see here it's a reverse motion. It's playing now in, and the timestamps are also correct now. So let's keep forwarding, and then yeah, let's look at some more interesting clips here. Yeah, This looks really cool. Okay, it's all the reverse motion now. Yeah, we are here now. So let's see some reverse effects. There you go. Let's start. Okay, it's interesting bit. Okay. Okay. Yeah, it's pretty cool actually. You can see here. You can. Yeah, that all those things you can watch here. So this is how you reverse a video with the help of FFMPEG APIs. Hope everyone have enjoyed this particular video. In the next sessions, we'll see how to reverse video and audio together and different combinations. We will also see how the playback control is happening, and I mean we have already seen it, but we didn't cover the audio aspects of it. So we'll cover that too. So until then, keep watching. Bye bye. Take care.